You'll see, like this is drawing D120, D121, 129. From these parts, that'll be the part numbers. And then you go right back to the parts list, and they correspond directly to a drawing and everything else. So if you ever need to order any spare parts, just use these drawings, and then go to the parts list, and that'll be, that's exactly how we'll get the parts back. Be able to order any spare parts that you need. There shouldn't be hardly any spare parts necessary. I think we set out a whole extra set of squeegees on the bottom, and the skimmer squeegee also on the top.
It's just going to get changed, I believe.
Yeah, we're actually looking at changing that out. So, and then we'll send new ones on those two from there. So, let's see what. Let me bring this page part up here again. I wanted to go through a few things. This is that submerged well. It's out of fiberglass. It's out of fiberglass and PVC. It's just hanging basically. There's hardly any weight to it, but this is all submerged. So the water it's very close to the bottom of the floor, so it just overflows it. It's one thing that was recommended. We've not built one with it before. It was recommended it was through both the city and the engineer that wanted to look at it and see what, because part of it helps the scouring of the solids instead of the hydraulics sometimes coming through the feed well and underneath will actually shove solids clear out to the outside. It likes to hit the bottom and just scoot along the bottom and then hit the wall and go up. And it's actually operating in some other plants, and they said that they've stopped that current from running the solids along the bottom. And so that was the intent, to keep the hydraulics from pushing the solids all the way. And so you have hardly any solids in the middle, and it just shoves it to the outside. So, and that was the intent of that wall, in essence. So, and we did, like I said, I call it an expensive guess, but we did some hydraulics. Well, you saw them, the hydraulic studies there, to see about what it looked like, and then tried to design the clarifier accordingly. So, with or without that wall, I think the piping will work fine.
Hitting the wall, now we can short circuit it right up and get right up in the longer faster. That's how it's going to work. Right? Crack does matter.
Well, again, we built it as the specs had it in there, so it was put in to see how that works in there. This is really an art, how you actually run your clarifier. We can come as close as we can and use a lot of really fun little tools. This was using Fluent to run some hydraulics and things like that through it, and to make an educated guess on it. But again, it's trying to guess settling rates, it's trying to guess hydraulic rates, and a lot of how fast you're pulling solids off. That'll affect where it goes. I mean, there's a lot of guesses inside of here too. So we did the best guess we could on it, and now the next is actually run it and see how it works and see what you need to do based on that. So, okay, I just wanted to go into the drive a little bit. The O&M manual again steps into the drive unit. There's a part on there's some sort of breakdown on every part, but I wanted to go into, this is your lubrication and maintenance schedule. This is probably one of your more important ones. And then down below it gives exactly what grease and hydraulic products you can use. And it also tells your filter type right in here, component list. Oh, spin-on filter, 25 micron. There's a DBS part number, but we'll get you a part on it. I think you can look at the filter and it'll tell you it's a Fram something or other on there. There's pretty well procedures on how to disassemble and do all parts here. This again is that main gear and how to take it apart. There's a troubleshooting guide, and that's the one I wanted to just that I have inside of here and it's pretty straightforward. Let's see, symptoms, troubleshooting guide. You should have 2 or 3 pages for it. Because it's a hydraulic box, so everyone have that, I guess, from there. So let's just open this up more so it's easier to see. It pretty well goes through everything, causes and problems that you might see on there. If it's not rotating, the terminals have come off. Either your shut-off switch may have activated. I'm not sure where the shut-off switch shows it activated. Is there a DCS or a main control panel?
Yeah, they'll get an alarm at SCADA.
Okay, so there should be both an alarm and then a shut-off that activate. So if that goes on, hopefully it's not set up. If it shuts off, it shouldn't start up by itself if the torque goes down. And it's run through the DCS on this one, but I hope someone has to physically go out there and kind of hit some sort of reset. But if the torque goes down, that it automatically starts up again. We kind of recommend against that. But I'm not sure how the DCS is set up that way. So someone should have to go on your SCADA or somewhere and actually physically reset it, and hopefully try to investigate why it's shut down.
Okay, so on torque shutdown, we will have SCADA, basically that motor's going to come up too, right?
Yeah, the motor
We'll
will.
have it where SCADA will not allow it to just automatically
Yeah.
start.
I mean, if it's pushing against it and it shuts down and then it kind of unwinds itself, there's a lot of energy in the arms. I don't want it to and just keep butting against something and then start, stop, start, stop. I don't want it that way. It should stop and stay stopped until someone investigates why it stopped.
Yeah, because they can restart it from SCADA, but the thing is they got to go out there, they would find
Right.
out what the problem is and be an alarm. Okay.
Right.
Make sure it's in SCADA that way.
And that is your sludge buildup's way high, something's fell in the tank, a chain, handle.
That's why we put chains on.
Something could have fallen in the tank. I mean, it's not inconceivable. I'm sure it's happened. So, yeah, so we don't want that one. Circuit breakers are tripped, the motor overloads. The box has been sized so the hydraulics should not heat up too much, but so it will, anyway. So there's a lot of different things of what reason there is, and they're just trying to give you some different reasons here to check out as you run through there. It could be that the motor's running but the rakes aren't. And what would that be an indication of? The motor's still turning but the rakes aren't going anywhere. So the pressure relief valve's off. Yeah, but it's funny that it shouldn't have shut down. That means your switches need to be looked at too. Then if they haven't shut it off, then something in the system isn't shut it down. But that's again your safety factor inside of there.
We're going to initially set all those up anyways.
Right, and we want to
Yeah,
test
we're
them
gonna
all,
test
and
them all,
yep, make sure that everything's there. I was talking with Walsh about what ways to do it. If it's not fully hooked up, we'll do a torque test, and we'll make sure that switches through the electrician that they either open or close or however. Because the switches are normally open and normally closed. I'm not sure how it's wired up, but we'll make sure that those shut down along the way on the torque test. And then again, using that test valve, we'll want to, whenever the DCS is hooked up, we'll want to do the same thing and make sure it shuts down, or alarms and shuts down at the appropriate torques. So if we simulate that up front and know the switches happen, and then later on they hook in the DCS, I mean, we'll know that it's good to there, and we just have to check the DCS side on things too. So these actually run pretty quiet. When they're running, you almost have to go up and make sure they're still running. Of course, you'll see it rotating, but because there's no oil in it, the hydraulic fluid's in there, but there's no grease or oil. There's no oil in the main bearing to spill or anything like that. So there's no condensate to drain. There's nothing in parts of that. Just need occasionally we'll screw this cap up and just make sure a good chunk of grease is in there and everything's getting greased in the, between the pinion and the main drive unit that way. I have seen occasionally on the gauge itself that the needle somehow came loose. And so it's sitting, it's not registering anything, but there really is torque. It's just the needle has come off the part there. And the needle can bounce because it's a hydraulic motor. So we just dampen it out by a valve. And so if the needle's not moving either, someone could have turned the valve too much. So you make sure it's off and then open it up a little bit. And then, so I've liked it when the needle's actually bouncing a little bit, then fluid's going to it. But it can get a wide swing if it's wide open from the pulses in the hydraulic. But as you step through, the O&M manual should have pretty well everything on the reducers. It's got, this is like the hydraulic drives. It'll have every piece of it will, there'll be some O&M, something in the O&M manual on fixing it or doing all the parts on there. So so it's pretty self-contained in that the main mechanism itself is just, it's all structural still. So it'll say one piece, a piece of brake arm. It's a 40-foot brake arm. It's, there's not like 20 angles that each have their own part number to it. It's just a one part number for half a rake arm. These are, they're relatively complicated from a point of a clarifier, but the idea that you can pull from whatever direction, any location on the floor that you get the most solids is, makes a benefit in the operations of it. It'll just, I think it'll take 3 or 4 months of operation to find out how to balance that the best. Because if you change one area, it can change everything else too. I mean, if you increase the flow in this area of solids through this pipe, that means less solids are going to get out to the other pipes. And so they could see a differential in them also. But I think once you get balanced out, then you can maintain it at that, and you just change your RAS rates, and it'll change, each pipe will change that same percent in flow through there, because it's as you drop that level in the RAS box, it'll increase the flow going through the, basically it's an orifice, a submerged orifice. So that head differential will change evenly across all 14 valves, and your flow should, percent should stay consistent through all the valves there. So how do you run, how does the RAS, how do you change the RAS? Is it pumped, or is it an overflow?
Well, it's exactly what you got now, same thing.
Okay, but there are pumps that are
Yeah.
pulling it down, that's what I
We'll
mean.
pull it.
Okay, some plants have it's an overflow weir and they drop the weir, some do it through a pump. Does that, do you change the RAS rates?
Yes, we do.
Okay. It's not based on flow coming into the plant?
It can be flow-based, in a new design.
Yeah, but we don't do that presently.
No.
We just,
Okay.
we're just
Just change it.
panicked, it says, once those blankets hit that 14-foot level, I guess it's time to slow them down. Oh, slow them down.
Okay, because this doesn't have a sludge blanket indicator on any
Yes, it
of them.
does.
Oh, it does?
Yeah, they're gonna have, sludge blanket indicators in
Okay. What kind of bed level detectors are they? Are they sonic ones that,
it. Yeah, I'm trying to think of the name of it, Royce, they're Royce,
the Royce ones?
yeah, because the other plant I'm working in has Baldry's.
Okay, they work pretty good, able to profile it pretty good? or-
Royce?
No, yeah, I've heard, add the
Well,
Royce.
we don't have them in yet, so we'll find
Okay.
out. I mean, I
But
know
I mean,
that
in the other
I've
plants?
seen them down south at a couple plants, and they appear to be working okay. But I mean, bottom line is they gotta be kept clean, and,
From a maintenance point of view, it's, I think, it's pretty straightforward. There's not a lot of maintenance on it. It's not like a weekly drain the condensate or anything like that. It's just, they have pretty well, once the 30-day thing is over, we'll have put new filters on it, and it's just change the filters every 6 months. And just remember to turn them off, because that pump will shoot the hydraulics right out. Just stop it for a couple of minutes, let it drain down in there, and undo the filter, There's a little part right on the side you can open up and actually physically see that there's fluid up in the basket where you pour it into. There's a little strainer basket right there. It is about 5 gallons. It says on one of these 6 gallons, yeah, of the how much hydraulic fluid to put in there. There's a drain on the bottom to get rid of the old stuff, and then the grease, you just add more grease into the main bearing if it looks a little low. So maintenance-wise, it should be pretty simple on the drive unit itself. Squeegees, I don't know why we get new ones on it. It's like every 5 years.
The squeegees
On the
what are those
bottom.
made out of?
They're stainless steel. The squeegees on the skimmer arms, well, you can see those. They're just like they're just a neoprene, heavy durometer neoprene on there. And then I don't know what else would be. Oh, that's one thing I didn't show you. There is a flush valve that can be adjusted as the skimmer comes by. There's a little tab on it basically that hits this arm right here, and it opens it up, and then it's counterweighted to shut it back down. So this arm here can be adjusted up and down to get the amount of flush water that you want to run through there to flush the whole thing through. Because the size of the scum box, there's also, let me get the scum box up. The size of the scum box, we didn't want it to be full of water when the tank was empty. That's a humongous amount of volume of water inside there. So there actually are 2 different types of valves under there. One of them is just literally a neoprene that'll close up, because you're going to have a differential of head inside of it, and it'll just close it up inside of there. The other one is, it's made by Red Valve. It's what do they call those things? It's
Duckbill.
Huh?
Duckbill?
Yeah, that'll just open up. It takes a little more pressure to open it up. But there are 2 or 3 inch size, so the biggest differential we should have is maybe a few inches inside as if you drain the tank, that scum box will drain also. Because of the way it's supported, it actually hangs off the bridge. It'd be a huge amount of water in there, and we just didn't want it to be full and the tank empty. And so so there's those 2 drain valves. We did 2 different types to make sure that if one plugs, the other will open up from there. So if you're draining it, you see water pouring out, it's meant on purpose to drain out of there. The launders themselves are actually, they're both ways. There's a stainless steel U-bolt, in essence, that holds them up from underneath also. I don't know if there's any holes in those. We didn't supply the launders. I didn't know if there's any minor,
I haven't seen any.
No holes.
no holes in it. Okay. I didn't know if they'd put a couple in there
You
that
can
sewed.
also backfill the one.
That's what I was thinking about. That's going to be part of the procedure.
Yeah.
Do some backfilling first to keep that thing down, 'cause that's a very light launder. That'll blow right out of there if you're not careful.
They're large. I mean, that's a huge boat in essence.